Okay, good day. This is dual enrollment pre-calculus. I am Mr. McCulley, and this is lesson number 32, dot products. Let's move right into it. So today we're going to find the dot product of two vectors. We talked about vectors in the last section. And then we're going to find the angle between two vectors. And again, when we talk about angle between two vectors, those vectors don't necessarily have to be touching. So just as a real quick example off to the side here, if I have something like this, I could talk about two vectors, one that goes like this, and then another one over here, and then discuss the angle that is between those two vectors, even though they're not touching. And then we're going to determine if two vectors are orthogonal, which is perpendicular. And so let's talk about some of the stuff that goes in the definition of dot product. So if I have two vectors, x1, x2, and a second vector, I'm sorry, I spoke wrong. If I have a vector u that is x1, y1, and a vector v that is x2, y2, then the dot product, which we're going to use by kind of a thicker dot than what we would from a multiplication, is going to be the product of the x's, the product of the y's, and then we're going to add those two things up. And so the dot product is not a vector, it is a scalar vector, or a scalar value, which is just a numerical value. The angle between two vectors in component form, if theta is the angle between two non-zero vectors u and v, excuse me, then the cosine of theta would be equal to the dot product of the two vectors over the product of the magnitude of the two vectors. Now, two vectors are orthogonal, and orthogonal means perpendicular to each other if the dot product is 0. And the reason that that is because when I take the arc cosine of 0, I'm going to get 90 degrees for the theta. And then two vectors are parallel if and only if the angle between the two vectors is 0, meaning that they are going in the same direction. They don't have any difference. Moving on, let's talk some examples here real quick. If I want to find the dot product of two vectors, remember that the formula that we're given is we multiply the two x values, we multiply the two y values, and then add those two together. So since I have vectors 2 times negative 5, I'm going to go 2 times negative 5, and then I'm going to add 2 times 3, 2 times 3, so I get negative 10 plus 6, and so the dot product of these two vectors, vector u dot vector v, is going to be negative 4. All right, next one. Find the angle between the two vectors. So if I have a vector that is given with the unit vectors and unit vectors forms, first thing I should do is convert those. And if we remember from the last section, converting those into component form is going to be 6, negative 2, and then vector v will be 8, negative 5. And so the angle between the two vectors, I'm going to look at this angle equation, and it is the cosine of theta is equal to u dot v over the magnitude of u times the magnitude of vector v. Okay, and so since I want the angle measure between those, I'm going to say theta is equal to the arc cosine to get theta by itself. And so u dot v, so 6 times 8 plus, let's see here, negative 2 times negative 5. And that's going to be over the magnitude of u. Well, the magnitude of u is going to be 6 squared plus negative 2 squared, and then times the magnitude of v, which will be the square root of 8 squared plus negative 5 squared, all in parentheses there. So let's do a little calculations before we get to the arc cosine here. And so let's see here. I got 6 times 8 is 48, and then negative 2 times negative 5 is 10, so I got 58 on the top. 36 and 4 will be the square root of 40, and then 64 and 25. How about 89? Square root of 89. None of that's going to be nice. So let's just go to the graphing calculator. Let's check our mode. Let's make sure we're in degree mode so we can quit out of that. That's good. Let's clear out of this. So go arc, cosine, and then I need a fraction. So alpha y equals, hit 1 there. And just go, let's go back here. So 58. So 58, and then on the bottom, it's second square root of 40. And then we're going to go times square root. Let's check and make sure. So 58, 89. 89 goes there. And come out of all of that, parentheses. Real quick, check my, let's see here. So 6 times 8 is 48, plus 10 is 58. 6 and 4 is 40, 64 and 25, 89. I think that's right. Okay. So arc, cosine, all that, hit enter. So our angle between two vectors is going to be 13.570 degrees. So 13.570 degrees. Close that up. All right, next question. If you are given that the magnitude of vector u is 4 and the magnitude of vector v is 12 and the angle between the two vectors is pi over 3, it says find the dot product of the two vectors. Well, we said dot product was the product of the x's and the product of the y's, and we could go through and we could actually with this information actually find those two component forms of the vectors. But if we use the equation, the cosine of theta is equal to the dot product. Oops, let's do this. Cosine of theta equals u dot v over the magnitude of u times the magnitude of v. I know what theta is, and I can take the cosine of it. That's a number. I can multiply these two products together, and I can say if I multiply right here, multiply both sides by the product of the magnitudes u times the magnitude of v, and that'll give me that the cosine of theta times the magnitude of u times the magnitude of v is the dot product. U dot, let's make that a bigger, thicker dot so that I know, dot v, which is what I want. So I don't even have to do all that work. All I've got to do is plug and chug. So the cosine of pi over 3 times 4 times 12. Well, the cosine of pi over 3 is a half. So remember our unit circle. Times 4 times 12. Half of 4 is 2. 2 times 12 is 24. So the dot product between those two vectors is 24. Next question, last question. Determine if the vectors are orthogonal. And so again, I have two vectors defined with the unit vectors. So first thing I'm going to do is say change u into component form. So I'll go 2, -2, and then vector v is -1, -1. And so if we draw this, right, and I didn't do a very good job of drawing those, so I want to fix those real quick so that we do see, in fact, that they are component forms of the vector. So 2, -2. So 1, 2, 1, 2, there's my -2, and then I've got -1, -1 would be right here. So these look to me like they're probably perpendicular. So it looks like they might be orthogonal. And so all we're going to do is we're going to find the dot product. We're going to say, all right, dot product of u dot v will be 2 times -1 plus -2 times -1, which will be 2 or -2 plus 2, which is 0. Now, we said up here that two vectors are orthogonal if and only if the dot product is 0. We found that the dot product is 0, so we can say that they are these two, u and v are orthogonal. Orthogonal. Now you can probably guess that most of them are going to be neither. And again, the reason that this we can shortcut it that if you get 0 for your dot product, they're orthogonals, because remember the cosine of theta equal to u dot v over the magnitude of u times the magnitude of v. Remember, we're going to take the arc cosine. And the only way that this fraction can be 0 is if the numerator is 0. So if the numerator is 0, the whole fraction is 0, and the arc cosine of 0 is 90 degrees, right? So, I mean, second cosine 0, not 1, come on, 0, hit enter, 90 degrees. So we're good there. And so they're just taking a shortcut. So if you find the dot product is 0, they have to be orthogonal. If it's anything other than 0, you actually have to plug it in and find the angle between. And if the angle in between is 0, then the two vectors are parallel. Well, that's all I got for today, folks. So, the Star Wars fun fact of the day: in Attack of the Clones, R2-D2 can fly with the use of rocket boosters, but he can't fly in A New Hope, which is actually supposed to come afterwards. And even though that movie was made earlier, what they did is they explained it in this expanded universe book that the manufacturer of those rocket boosters that you see in the picture actually goes out of business. So sometime between Return of the Sith or Revenge of the Sith and A New Hope, R2-D2 damaged the boosters and was unable to get a replacement. Kind of a weak explanation. But what else are you going to do? A New Hope was made in 1976, and uh, um, let's see here, Attack of the Clones was made sometime around 2002. So big difference in times. There you go. Have a great day. Bye.